For part A, they give us the coordinates of 2 points A and B. A is at -3, -4. B is at 2, 6. And they want for this line segment to calculate the midpoint. The midpoint is given as x1 plus x2 divided by 2, y1 plus y2 divided by 2. Let's label our points. We have x1, y1, x2, y2. Filling out the equation, we're going to have -3 plus 2 divided by 2, -4 plus 6 divided by 2. That's going to give us -3 plus 2, that's -1. -1 over 2, that's -1/2. -4 plus 6, that's 2. Plus 2 plus 2 divided by 2, that's 1. The midpoint is at -1/2, 1. The gradient is given as y2 minus y1 divided by x2 minus x1. So that's going to be y2 is 6, y1 is -4. That's 6 minus -4 divided by x2 is 2, x1 is -3. That's 2 minus -3. Therefore, we're going to have 4 minus -4. That's 6 minus -4, that's 6 plus 4, that's 10. We divide that by 2 minus -3, that's 2 plus 3, that's 5. The gradient is going to be 2. Part 3 wants us to find the equation of the perpendicular bisector of AB. So if this is our line AB, the perpendicular bisector cuts AB at its midpoint and it cuts at an angle of 90 degrees. So the equation of the perpendicular bisector would require its gradient and one point on the line. The gradient of the perpendicular bisector of a line is going to be the minus inverse of the line's gradient, meaning we take the gradient, we take 1 over the gradient, and we take the negative of that. That's going to be 1 over 2, and it's the negative of that, so it's -1/2. 1 point on the perpendicular bisector would be the midpoint of AB because the bisector passes through the midpoint. That's -1/2, 1. Setting up the line equation, y minus y1 is equal to m into x minus x1. So y minus 1 is equal to -1/2 into x minus -1/2. So y minus 1 is equal to, we have -1/2 x, then we have minus by -1/2, this would be +1/2, -1/2 by +1/2, that's -1/4. We have then y is equal to -1/2 x, and we add 1 to both sides, so we have 1 minus 1/4, that's +3/4. Now we could leave the equation in this form, or we could multiply throughout by 4 to get rid of the fraction. So we see that 4y is equal to -2x plus 3. Part B tells us that another point Z has coordinates -5, -8. They want to show that the points A, B, and Z are collinear. So A, B, and Z must all lie on the same line. So if we have a point A here and a point B here, then Z must be on that same line. So that means if we find the equation of the line segment AB, then Z should lie on that same line, meaning the points that make up Z, the points of Z, should satisfy the equation of AB. Let's get the equation of AB. The gradient was 2. 1 point on the line was 2 and 6. So we have y minus y1, which is 6, is equal to m into x minus x1, which is 2. So y minus 6 is equal to, and m was 2, that's going to be 2x minus 4. Therefore, y would be 2x, and we add 6 to both sides, 2x plus 2. So let's now test and see if this point does lie on that line. So if it does lie on the line, then these points should satisfy the equation. meaning minus 8 should be equal to 2 lots of minus 5 plus 2. So minus 8 should be minus 10 plus 2. And yes, minus 8 is indeed the minus 8. So the 3 points are indeed collinear. Part 5, we have a frequency table showing the number of goals scored in a series of football matches. They told us that the mean number of goals scored is 2.2. They want us to determine the value of k. For frequency tables, the mean is given by the summation of f of x divided by f, where f is the frequency of occurrence and x is the value that we are interested in. So we see that 0 goals were scored in 3 matches. That means that that's a total of 0 goals. Let's label this. So this is going to be x, and the number of matches would be f. Right, so if 1 goal was scored in 10 matches, that's a total of 10 goals. 3 goals in 15 matches, that's 45 goals. So let's fill out the rest of the table. 2 by k is 2k, 4 by 4 is 16, 5 by 3 is 15. Right, so let's add up all of these. That would be the summation of x multiplied by f. So we have 0 plus 10 is 10, 10 plus 45, that's 55, 55 plus 15, that is 60, 60 plus 16, that is 76. So we have 76 plus 2k, and that's divided by f, or the summation of f rather. So that would be 3 plus 10, that's 13, 13 plus 3, that's 16, 16 plus 4 is 20, 20 plus 15, that's 35, and we have to add k. So that's 35 plus k. And they told us that the mean is equal to 2.2, therefore 76 plus 2k over 35 plus k is equal to 2.2. Right, then we could multiply both sides of the equation by 35 plus k. So we see 76 plus 2k is equal to 2.2 into 35 plus k. So 76 plus 2k is equal to 2.2 by 35 is 77, and we would have plus 2.2k. Right, bringing all the k's to one side of the equation, we see that 76. Oh, I feel like I made some sort of error here. Okay, so 10 plus 15, oh, not 10 plus 15. 10 plus 45 is 55. 55 plus 15 is 70, so this would be 70 plus 6, this would actually be 86, my bad. Right, so we would then have 86 minus 77 is equal to 2.2k minus 2k. So we see then 9 would be equal to 0.2k. Therefore, k would be 9 divided by 0.2. K would be 45. Moving right along, we see Teacher Joy recorded the time taken for 60 students in her math club to complete a 12-piece puzzle. We have a cumulative frequency graph to show the information regarding the time it takes the 60 students, to complete the puzzle. Part 1 wants us to use the curve to determine the probability that a student chosen at random will take at least 42 seconds to complete the puzzle. Okay, so let's look and see where 42 seconds reads. And it's at least 42 seconds, so they could take 42 seconds or more. So 42 seconds would be between 40 and 60 is 50, so each one of these points here would be 2. 42 would be right here. Okay, so that seems to be okay. That's a little bit off. 42 would be on this particular line here. Right, so that seems like it would be around 15. Right, so 15 students took less than 42 seconds. So how many took more than 42 seconds? Well, it would be the total minus that 15. Okay, so let's get that. So 15 took less than 42 seconds. Therefore, the amount that took more than 42 seconds would be 60 minus 15. So 45 students took more than 42 seconds. Let's now get that as a probability. So the probability of a student taking more than 42 seconds would be 45 over 60, and that's going to be 3 over 4. Part 2 wants us to determine the semi-interquartile range of the time taken by the 60 students to complete the puzzle. Well, the semi-interquartile range would be a half of Q3 minus Q1. Q1 would be n plus 1 over 4. Q3 would be 3 lots of n plus 1 over 4. N is the number of students. In this case, it was 60. So Q1 would be located at that 60 plus 1, 61 over 4. That's going to be 61 over 4. That is 15.25. So that's approximately the 15th value. And then Q3 would be at that 60 plus 1. That is 61 multiplied by 3 over 4. Let's calculate this. That works out to be around 45.75. So that's approximately the 46th value. So Q1 is at the 15th value, Q3 is at the 46th value. Let's get both of those. Right, so first let's get, right, so we already have Q1 marked there. That's going to be 42. Then let's get the 46th value. So that's 40, here's 45, 46 would be, this graph is a little bit bent. Let's see if we could get this as accurately as we could. Right, so that seems to be at, so this is 60, in the middle here will be 70. So each of these marks here are 2, so this would be around 60, this is 64. Right, so we have 64 and 42. Let's fill that into the equation. Right, so Q3 minus Q1 would be 64 minus 42. That's going to be 22. Right, so then the semi-interquartile range would be one half of 22. That's going to be 11. Part 3 wants us to complete the table below. So we have to find the number of students which matches these particular ranges. Right, so we look for the upper class boundary. So that's going to be, here we have 40.5, here we have 60.5, 80.5. Right, so let's see what those values are going to be. And so let's mark in those upper class boundaries. So the first one is at 40.5. Then we have 60.5. Then we have 80.5. And that's close enough. The graph itself is a little bit bent. So let's then read across. So we have and so that seems to be at 10, or this is at exactly 13. Right, then here we have, this should be, it isn't that accurate. This should be at around 40. We'll call this 41 because of the way the graph is irregularly shaped. So this is around 41. Then at 80 we would have, we'll call this, let's see what that lines up to be. So between 50 and 60 we have 55, 56, that's going to be 57. Okay, so let's see if you can determine what those values are going to be. So between 41 and 13, what do we have? So 41 minus 13, then 57 minus 41.